Hi everyone, welcome to the second last video of separation techniques. This video is all about sublimation. As you can see over here, I'm trying to draw a solid that is able to turn straight into vapor. That's what sublimation is. Sublimation is a very unique process of where one state changes to another. We are very used to solids having to first melt to become a liquid, and after melting to become a liquid, then it boils to become a gas. However, what if we skip the entire process? What if a solid becomes gas immediately? That is what sublimation is. Sublimation is a process where a solid becomes a gas. It skips the process of turning into liquid first. I think you're already familiar with one solid that is able to carry out this process of sublimation. You may have played once with dry ice, right? What is dry ice? Dry ice is actually, if you did not know, solid CO2, solid carbon dioxide. What's so special about solid carbon dioxide is that it doesn't first melt into liquid carbon dioxide. Instead, it immediately turns into gaseous carbon dioxide, the usual carbon dioxide you are familiar with. And that is sublimation, right? We often use dry ice to keep our ice cream cakes cool, to keep ice cream cold for a very long period of time. Dry ice is an example of a solid that is able to go through the process of sublimation from solid straight to gas. And so, how do we separate things using sublimation? Well, if you notice, all of the separation techniques so far goes back to the basis that we are looking for a property where both substances have a slight difference in. In this case, we are looking at sublimation points. Rather than boiling points, we're looking at sublimation points. So what do I mean by that? We are looking at whether two substances have different sublimation points. For example, let's say I have a mixture of sand and or maybe salt. Let's say I have a mixture of, I'll go back to sand. Let's say we have a mixture of sand and iodine. Okay, sand and iodine. Let's look over here. Here I have a mixture of sand and iodine. Sand as well as iodine. Iodine, what is iodine? Iodine is an element. Okay, iodine is an element. Now, how are we going to separate iodine and sand? We've learned one way of separating solids, right? If they have different, if one is magnetic and the other is non-magnetic, we technically could use a magnet. However, iodine and sand both are non-magnetic. Are they different in size? Well, actually, on a microscopic level, yes, they do look slightly different in size, but how are you going to filter this, right? How are you going to actually filter this? It's not like you have a sieve that's able to do this, right? This separation technique. So let's try something new. Let's try sublimation. Well, how does sublimation work? Iodine actually sublimes. Meaning to say, just like carbon dioxide, if you turn up the heat, supply a little bit of heat, it immediately turns into gaseous state. Okay, wrong color. It immediately turns into gaseous state. But yes, it's turning into gaseous state, but we have a problem. If it turns into gaseous state and we just let it evaporate away, then I'm technically losing the iodine. I'm not going to get it back, right? So how am I going to get back the iodine after it has evaporated away? This is how I can get back the iodine. The iodine can condense back on the inner surface of what I've put over here is a flask. Sorry, not a flask, it's a funnel. Okay. This is a filter funnel that I've just inverted and placed on the very top. And I've also put a lid to make sure that the iodine doesn't just evaporate away. Right? So what's happening here? The iodine, as it undergoes sublimation, it immediately condenses back into its solid form over here, and it collects over here. It collects back over here as crystals. So what's happening on a microscopic level? This is what's happening on a microscopic level. The iodine, as it's gaining more thermal energy, rather than turn into liquid state first, it immediately turns into gaseous state. It immediately turns into gaseous state, immediately turns into gaseous state. Right? That's what's happening. This is what we refer to as sublimation. As it goes into gaseous state, it rises up. Right? This is what's happening over here. If I were to zoom in. And as it rises up to the top and it comes into contact with the inner wall of this funnel, this is what's happening. Let's zoom in over here. As it's rising to the top, okay, let me grab onto let's grab one of these molecules. Okay, so it's rising to the top. Okay, rising to the top, and then it will condense back into its solid form or its crystal form. And so in a sense now, I've managed to carry out and separate the two substances from each other. I have here pure iodine, and I have here what's left over would be just sand. I've successfully separated out two molecules, two different substances based on sublimation points. Right, made use of the fact that iodine can sublime or undergo the process of sublimation. And this is a very simple technique, but only works with solids that can undergo sublimation. This is what the setup actually looks like. Here you can see again this white ceramic bowl. This is what we call the evaporating dish. You've encountered this before. It's made out of ceramic, so it can withstand quite high heats. And then over here you see it's actually just an inverted filter funnel. And of course on the very top of the filtered funnel I need to seal it up so that the gas doesn't just go off into the atmosphere. You can see on the inner walls of this filter funnel, you can see the iodine crystals actually collecting on the inner walls. What's below is the mixture of the iodine and whatever was in there. Alright, so that's a very simple technique, sublimation. Are there other solids that can undergo sublimation other than what I've introduced to you, iodine as well as dry ice? Yes, there is a solid called ammonium chloride that can also undergo sublimation. Another chemical that can undergo sublimation is naphthalene. Naphthalene is actually something that you may have at home. It can be found inside mothballs. Mothballs aren't actually moths. They are those balls that you find inside of cupboards to keep to make sure that it doesn't get the scent inside of your cupboard doesn't get very musty. Right? So these are examples of solids that can undergo sublimation. If you ever see these solids, if you ever see the solid dry ice, if you ever see iodine, if you ever see naphthalene, if you ever see ammonium chloride, then you can make use of the process of sublimation. Okay, and that's all for sublimation. Thank you, and I'll see you in the next video.